Hello guys, welcome. Good evening everyone. Am I audible to you all? I hope I am audible to you. Just confirm me once. Okay, I guess some noise is there. Yeah. Is it clearly visible or inaudible right now? Just confirm me. So that I can start today's session. Can you guys please give a thumbs up if everything is fine? I'm waiting for you. Please like the session and give a thumbs up in the comment section so that I can know that everything is fine or not. Okay, so just uh, let, let me give some minute to everyone join this session and we'll start in a minute. Okay. All right. So we'll start, right? Okay. So you know that Geeks is conducting the online batches, and the online batches are of DBMS, theory of computation, that is automata, and computer organization and architecture, right? So, and you are getting those courses at 699, and you are also getting the the okay, wait a minute. Okay, so you are getting also the get test series at 799, but the big thing is that you can get these all these courses and as well as the test series at rupees 0. Okay, you can get those in what happened here? Just let me check. Okay, it's fine. Yeah. So all of these courses as well as the test series you can get at rupees 0. Okay. How can you get that? So if you are you are a repeater. Okay. So if you have given the gate 2020 or gate 2021 already, and if you are willing to give one more time a chance to get, then there is a big announcement from our side that you can avail all these courses as well as the test series, which is the most important to you all, I know. So you can get this at rupees 0 only. So what the minimum thing that you need to do, so you just need to fill up the form that is given in the description. So just fill up the form given in the description. There is a Google form given in the description, and what you need to give there, you just need to give your gate scorecard. Okay, you just need to give your gate scorecard. You can see from here. Okay, so you just need to give the gate scorecard, and you will be eligible to get a discount of up to 100%. Okay, so this 799 get course plus this 699 into 3 courses, all of these things, so it's almost it's almost 280, so it's like 28796. Okay, so all of these things you are getting at rupees 0. Okay, so what the least thing you need to do, you just need to give your scorecard in the below Google form. Okay, and you need to fill your all the details that is mentioned over here, and you will be eligible up to 100% discount, right? So just don't delay, just go to the description and fill up the form after this session, not right now, because I'll be going to discuss some important concepts here, and after, as soon as you finish this session, so just go to the form description, in the description you can get that, and you can fill out that form. Okay, so this is specifically for the repeaters. Okay, so repeaters who have get in 2020 or 2021. Okay, so fill up the form, and obviously also for the current year aspirant, like 2022 aspirants only, like if you are not any repeater. Okay, so therefore also you can avail this feature. You also can avail this feature. Just you need to connect with us. Just connect with us, and you just write to us in our mail ID, that why you need this offer, and we will consider if your reason is genuine, and we will see if you can get the discount offer. Okay, so just fill up the form or write a mail to us, right? Okay, so with this we will start our today's session. Okay, so we'll be discussing about the year diagrams and the relational model. So this is the very first topic, I know, but this is the quite often neglected topic by the students. So I'll be discussing this on today's session, and we have more questions than other days. So you have to be very fast in today's session. Be very first, okay? You have to be very quick in today's session. Okay, so with this we'll start the session and start the questions. I would like to see if you can answer before me. Okay, so this is the first question, and it is saying that given the basic year and the relational models, which of the following is incorrect? So you need to find out which of the following statements is incorrect. Okay, so for the year diagram and the relational model, which one is the incorrect one? So the first one is telling us an attribute of an entity can have more than one value. Okay. Second one, an attribute of an entity can be composite in a row of a relation. Okay, so this is the second one. And in C they're telling in a row of a relational table, an attribute can have more than one value, and in D they're saying in a row of a relational table an attribute can have exactly one value or a null value. So just give me the answer, which is the correct option. I'll be giving you a 30-second time because this is a very easy question. Okay, so it's a straightforward theoretical question. I'll give you 30 seconds to do this one. Tell me the answer. Correct option. I'll be giving you a 30-second time because this is a very easy question. Okay, so shall I start with the solution? Okay, so it is saying that an attribute of an entity can have more than one value. So it is saying that an attribute of an entity can have more than one value. Obviously it is correct, because why it is so? Let's say you are having a entity called price. So you are having a the attribute called price. So you have a the book table. Okay, so there is a book, and there is a book ID. There is a book ID, and there is some other things also, and you have a price. Okay, so an attribute of an entity can have more than one value. What it is saying? So it is saying that it can have more than one value. How it is possible? So let's say the book is sold in let's say in one country. not one country, in one state. Let's say if the book is sold in the state of West Bengal, it is having some one price, and if it is sold in some other country like Maharashtra, then it is having other price. Okay, so it is allowed that multi-valued attribute is allowed, right? Multi-valued attribute is allowed. But what is the catch here? That multi-valued attribute cannot be placed in the single row. Okay, so you need to have multiple rows for that. Like if you want to have, let's say if you want to have West Bengal and the price is, let's say, 200, and in Maharashtra you have the price of 300. Okay, so you need to have the same book ID two times. Okay, why it is so? Because there is a multi-valued attribute for the same book ID. There is a multi-valued attribute, but what you need to do here, you have to have two different tuples for this. So in a single attribute it is not possible. Okay, so it is telling us an attribute of an entity can have more than one value. Okay, so it's a possible thing. Okay, so because it's not saying about that it will be it should be there in one row. It is not saying that, but it is saying that an entity can have more than one value. So it is possible for the multi-valued attribute, right? For the multi-valued attribute it is possible. And the second one is saying an attribute of an entity can be composite. Obviously it can composite. How is it so? So let's say you have a attribute called name. So name has two or three parts. Let's say the first name, the middle name, and the last name. Okay, so all this thing together will form the name attribute. Okay, so these are the sub attribute of name. So this is called the composite attribute. So this is also the correct, it is also true. It is also true and it is also true. And the third one is saying in a row of relation table, an attribute can have more than one value. So the first one it is saying in a different way. So it is saying that in a single tuple, or in a single row, you can have multiple attributes, or you can have multiple value for one attribute. But this is not possible. You cannot have price like 200, 300. This is not possible, right? So this is not the case. So this is false actually. So which one is the incorrect? And the third one is saying in a row of relation table, an attribute can have exactly one value or the null value. Obviously, you can see that price can have either one value or it can have a null value also. Okay, so this is also true. So the incorrect one is the third one. So our answer will be C. Got this one? Everyone got this one? Please confirm me if you have got this one. Is it clear to you? Okay, so shall I move on to the next one? If there is no doubt, can I move on to the next one? Okay, can I get any confirmation from you guys? Let me know this one, which is the answer of this. Okay, so let's solve this one. Anyone with the answer? Okay, so solve this one. Okay, so it's saying that suppose A and B and C and D are two relational schemas. Okay, and let R1 and R2 be the corresponding relation instance. So let us consider this is R1, A and B, and A is the candidate key, and we have R2, which is C and D, and where C is the candidate key. Now R1 and R2 are the corresponding relation instance. B is the foreign key that refers to C in R2. So B is the foreign key that refers to C in R2. Okay, so B is actually taking the values from C. So here B references C, right? So B is the referencing attribute, and C is what? C is the referenced attribute, right? This is quite important concept, referenced attribute. Reference attribute. B is the referencing attribute and C is the referenced attribute. Okay. So what do we know by this kind of thing? So it is actually a foreign key, and if data in R1 and R2 satisfy the referential integrity constraint, obviously it will be satisfying the referential integrity constraint, then which of the following is always true? If then which of the following is always true? If then which one of these given options will be true? So when it will be true? Okay, let's see. So actually we are having these two. So R1 is the relation and R2 is the relation, and B is taking the values from C, right? So by the foreign key, what we mean? So whatever the values of B, all the values of B should be always present in C. So B cannot take any value which are not present in C. So let me write this statement. So B always takes value from C. This is one thing. Second one, B cannot have value which are not in C. Which are not in C, right? So what does this mean? So it means if I take the B, if I take only B, okay, and if I take pi of C, so these are actually what projection, okay. So if I take this R1 and if I take this R2, okay, so and we are doing what? So you can see we are doing the set difference operation, right? So what is set difference operation? So we have a set over here and we have a set over here, and what we do, A minus B. While doing A minus B, what is the answer? So the elements present in A but not present in B. So this part will be A minus B, right? So this is the A minus B part. So the elements present in A and not present in B. Okay. So if I consider for this part, if I consider for these two parts, so the elements that are present in B, so actually you can see elements present in B but not in C. So is this possible at all? Is this possible at all? Let me see. Tell me if it is possible or not. Elements present in B but not in C. Is this possible? So actually we are taking all the values of B which are already present in C, and we cannot take any other values of B that are not present in C, right? So all the values that are in B should be also in C, and so the elements present in B but not in C cannot be anything, because present in B but not in C, can we have anything that is present in B or not C? Because let's say, is this possible? We have, let's say, 2, 4 and 5, and we have only 2 and 4 here. So we have 5 here but 5 not here, okay. But is this following the referential integrity constraint? No, because it says that B should always take value from C, but 5 is not present in C, so 5 we cannot take here. So all the values present here should also be there. So actually the elements present in B but not in C should be empty, right? So this is the case here. So what will be our case? So our case will be pi of B minus pi of C will be equals to 5, right? So you can see that the first one is following the given condition. So pi of B minus pi of C should be empty one, okay? Can you get this one? Please let me know if you have any doubt with this one. Any doubt with this one? Can I get any confirmation from your side? Just like the session and join. We are solving very interesting questions right here. Okay. So can I have more participation? Participation. Okay, so can I move on to the next question? Please let me know if you have any doubt, or else I will move on to the next question. Okay, so let's move on to the next one. If anyone does not have any doubt, so let's move on to the next one. Okay. Okay, so this is the next one, and this is very interesting one also. Okay, so this kind of question you generally get. You generally get this kind of question. Okay, so tell me which is the answer. Tell me which is the answer of this one. So they are saying the minimum number of tables needed to represent this kind of ER diagram. So given this ER diagram, you need to find out the minimum number of tables needed to take 30-second time and give me the answer. It's an easy question, but it's an important question, because this kind of question you often get. If not in GATE, obviously you can expect this kind of question in GATE, but this kind of question is very common in ISRO and BARC also. Okay. This is very conceptual question, and I will give you a trick to solve this kind of question. There is a trick to solve this kind of question. If you don't know this one, please like the session. Okay. All right. So let me tell you the trick of this trick of solving this kind of question. Okay. So you can see here. So do you know the meaning of this double line and this arrow here? So the double line is meaning what? You must be knowing this kind of thing. So double line means what? Double line means total participation. Total participation means what? Total participation means all the entities, all the values or all the elements present in the particular entity should participate in the relation. So this is total participation. If you have a single line, okay, this single line means the cardinality is many. Okay, and if you have an arrow like this, the cardinality is 1. Okay, so if you have a relation like this, if you have a relation where you can see that there is a straight line like this and there is a arrow like this, so it is actually a many to one relation. So this is actually a many to one relation. Okay, so while solving this kind of question, you have to many people get confused with this kind of question, but I will tell you the trick to solve this kind of question. Okay, so let me write the trick for you here. Actually the trick is here is very simple. What it tells, so actually when you have a many to one relation, you can have many to one relation, you can have many to many relation, okay, and you can have one to one relation, right? So can you identify which kind of relation is this? So this is actually a many and having a total participation this side. So it is actually many and total participation, and this is actually a 1, and this may not be a total participation. This is not a total participation. It's a non-total participation, a partial participation. Okay. So this is actually one side, and this is actually a many to one relation. Many to one. So while given this kind of question, just think of only one side of the relation. So the one side of the relation is telling us this kind of thing, this kind of story. So we have a relation like this M, and we don't have any the multi-valued attribute. Whenever there is no multi-valued attribute, you need not to think anything about these attributes also. Okay, whatever be the attributes, if it's not multi-valued attribute, don't think about them. So you have a relation entity M, and this is a relation R1 and you have a one P. Okay, so this is a many to one. Okay, so actually what we need to do, we have to build some table for this relation, for these entities, right? For entities we need to have table, but can we merge this relation attribute? Can you merge this relation? There is a relation, right? And for some time we need to build a separate table for the relation, but as this is a many to one relation, we can say that we can merge this relation table with the many side of the table. So actually what we can do, we can merge the relation with many side, with the many side, right? What is the many side? That means you have a many to one relation, therefore you can merge it with the many side. And which is the many side? We have the m as the many side. So you can think of like this. So you have having a relation like this, m r. Okay, so this is one relation. Okay, and you have another relation over here, this is n, and you have another relation over there, right? Okay, so there is a r2 over there. Okay, sorry, so you have n over here, r2 over here, and you have p over here, right? So again you are thinking of this part only. So again you can identify that this is a many part and this is the one part. So again what you can do, you can merge the relation table with the the relation table with this entity table of the many side. So what you can do, you can merge this table, this R2 table with n, right? So here you have m R1 and you can form also here n R2 table. Okay, so you can form n R2 table, and finally what you are left with, you are left with this P relation, okay, or the P entity. So you are left with this P entity. So how many tables actually you are needing? So you are needing actually 3 tables, right? You are actually needing 3 tables. And what are the tables? They are m R1, they are n R2, and they are P. Okay, so this is entirely one table, this is entirely one table, and this is the another table. So you have 3 tables to be made. Okay, and one more thing, that you saw the many to one relation this side. Okay, but if you have a many to many relation, if you have a many to many relation, what you can do, for many to many relation, you cannot merge the relation with entity. Cannot merge relations with entity. Okay, so if you have a relations like this, let's say this is A1 and you have a relation like this R, and you have another relation A2. Okay, so this you can see here, there is a M to N, like the many to many relation. Okay, so as this is a many to many relation, you can say that you need to have one table for this one table for this one, and obviously one table for this relation also. So for this case, you need to have 3 tables for this 2 entity attribute or 2 entity table. Okay, so you need to build a table for this relation also. Okay, we'll see this with an example. Okay, so let's take the example of this one. What is this saying? It is saying that let E1 and E2 be 2 entities in an ear diagram. Okay, so let's draw the ear diagram here. So we have E1 entity and we have E2 entity over here. Okay, with simple single valued attributes. Okay, so all the attributes will be single valued, and we don't have any multi-valued attributes, so no need to worry about the attributes. So we have the single valued attributes. R1 and R2 are 2 relations between E1 and E2. So we have 2 relations. We have this one relation, which is R1, and we have another relation which is R2. where R1 is a 1 to many and R2 is many to 1. So let's say R1 is 1 to many, so this part is 1, okay, and this part is many, so this is one part, this is many part. So R1 is a 1 to many and R2 is many to many, okay, so the R2 is many to many, okay, so we'll be having only a straight line, no arrow will be there for many to many and many to many relation. And R1 and R2 do not have any attributes on their own, so these relations do not have any attribute, so we don't have any kind of attributes here, okay, so no attributes are there. What is the minimum number of tables required to represent this situation in the relational model? So can anyone answer this one? What is the answer of this one? Anyone with the answer? Okay, so this one will be what? So we have a one to many relation. So whenever you are having a relation, just think of this relation. So just think of this part only, okay? We'll be thinking of this part. We will, okay, this is very right. Okay, so this one, so you can think of this part entirely first, okay, this part we are thinking of, so we'll be dealing with this part. So this is E1, we have a one to many relation, let's say this, and we have this, okay, so here you can see that we have a one to many relation. So one to many relation, so for this one to many relation we can merge the relation with the entity of many side. So there will be one table for this one, so one table for this one and one table for this one, okay, so the entire thing becomes like this, okay, so the entire thing becomes, it is becoming E1 and we have another R2 and this part becomes E2 R1. Okay, so it becomes E2 and R1 and both of them are many to many, okay, so this is a many to many relation. So as I told you earlier that a many to many relation needs a separate table for the relation, right? So we will be having one table for this one table for this one, because it is a many to many relation, so we will be having a table for the relation also, and obviously one table is there. So how many tables we need? So this one table is this table, right? This table. So this one table is this one table. Okay. So after merging this one, we got this E2R1 table. So we have 1, 2 and 3 tables in total. So our answer will be 3 tables. Okay. Our answer will be 3 tables. Okay. Anyone have any doubt with this one? Anyone having any doubt can ask me right away, otherwise I will move on to the next question. So can I move on to the next one? So this is the next one. What it is telling us? This is a very beautiful question and this is an important question also. This is an important question. Guys, please solve this one. Please solve this one. This is an important question. So what is telling? What it is telling? It is telling what is the minimum and the maximum number of tables required to convert an ER diagram with two entities. So again we have two entities, let's say E1 and one relationship between them. So we have two entities, E1 and E2, and we have a relation between them. Let's say this is R1 relation with partial participation constraint of both entities. So we have a partial participation constraint. Both the entities are of partial participation. Okay, so we have to deal with the minimum and the maximum number. So the maximum, when can we get the maximum? We can get the maximum when there is a many to many constraint, right? Maximum can be got when we have many to many cardinality ratio. When we have a many to many cardinality ratio, then we will going to get a maximum number of entities, right? So how many entities we are going to get? So for this one entity we are going to get one table. So for this one we are going to get one table, this one table, and as I have told you that the relation would require a separate entity taking the candidate key of this one and taking the candidate key of this one. Let's say the candidate key of this one is C1 and candidate key of this one is C2. Okay, so let's say the candidate key of this one is C2. So our this relation will have a entirely separate table. So this R1 will be having a table and which will be consisting of this C1 and C2, and both of them together will consist the candidate key. Okay, so C1 will be brought from here and C2 will be brought from here. C2 is the candidate key in E2 and C1 is the candidate key in E1. So in this case we will have one table for this one table for this one, and one table for this one. So total we can get 3 table in maximum. Okay, and the least or the minimum is a little bit tricky here. Why? So when we actually can get the minimum number of table, let's say we have an E1 here, a relation over here, and the entity over here. When we can actually get the minimum number of table, when we have a one-to-one relation. When we have a one-to-one relation, and let's say any of the tuple, any of the side is actually participating totally. Yeah, right, max is 3. You're saying the option is C. Okay, let's see whether it is C or not. Okay, so we'll be having a minimum side in either side of the the relation. If we have a total participation, then this 1-to-1 cardinality ratio always generate one table. So this entire thing can be brought down into one table. Okay, if we have at least one side of the participation as total participation. But what it is given over here, we are given that both the side is contributing partially. Okay, so as both the side is contributing partially, we can say that there is a 1-to-1 cardinality ratio, but both of them are partial participation. Both of them are partial participation, right? As both of the side are participating partially, so we can say that we cannot merge this entire thing into one table. So either we have to merge this relation with this entity, or we can do this merging of this entity. Okay, so in this case we need a minimum of 2 tables. Okay, so the minimum number of tables required is 2 and the maximum number of tables required is 3, right? So this one is the answer. Yeah, C is the answer, correct. Okay, so anyone with any doubt with this one? Do anyone have any doubt with this one? You can ask me. This was a very good question and an interesting question also. You can expect this kind of question in GATE exam also. So shall I move on to the next one? Any doubt with this one? If any doubt, you can ask me right away. Okay, so let's move on to the next one. If you don't have any doubt, we can move on to the next one. Okay. So it is saying that in an entity relationship model, suppose R is a many to one relationship from entity set E1 to entity set E2. So we have two entity set E1 and E2, right? E1 and E2, and R is a relationship, is a many to one relationship from E1 to E2. Assume that E1 and E2 participate totally. So this is a many to one relationship. So this is a one side, let's say, and this is the many side. Okay, and totally in R, that is that the cardinality of E1. So we can say that cardinality, or we can write this like this: cardinality of E1 is greater than cardinality of E2. Okay, the cardinality of E1 is greater than the cardinality of E2. Okay, then which of the following is true about this? Which one is true? So as you can see that many tuples, and both of them are total, obviously both of them are total participation. It is given over here, participate totally. So you can see that this E1 is participating totally, and it is participating in a cardinality of many. Okay, so you can say that many entities, right? So many entities from E1 is actually associated with exactly one entity of E2. So actually many entities, if you have an entity set like this and entity set like this, so actually from here many entity set can be mapped to exactly one entity set. Many entity set can be mapped to exactly one entity set like this. So this is E1 and this is E2. Okay, so here you can say that which one of the following is true. So it is saying that every entity in E1 is associated with exactly one entity of E2. So this one is the first one, and this can be true, right? Let us see for other one. Some entity in E1 is associated with more than one entity of E2. This is not correct because this is actually a one side participation. This is a one side participation, so it cannot be more than one. Here it is telling that every entity of E2 is actually associated with exactly entity of E1. But we know that E2 is one side and E1 is the many side. So this is actually the opposite case. And here it is saying that every entity of E2 is associated with at most one. No, not at most one. Why not at most? So at most means you can have some thing which is not participating also. So you can have like this and which is not participating. So at most one means like that. But we are seeing that it is actually a total participation, right? It is a total participation. And what does total participation means? Total participation means all the entities should participate. So you cannot have one entity which is not participating. So it is not at most one, it will be exactly one, right? So our A will be the answer. Okay, I hope you got this one. Is it clear to you all? So with this, I'll move on to the next question or the last question. So this is a very easy question. This is actually a theoretical question and you have to deal with it. So what it is telling, you have to match the following, right? Match the following tuples or match the following columns. Okay. So the first one is the entity integrity. What does entity integrity mean? Entity integrity means that you have to have exactly, what it says actually. Valid column you have to have. Sorry, the entity integrity says that you have to have. It is actually satisfies the 1NF property. It is actually satisfies the 1NF property. And what is the 1NF property? It is actually the atomicity property. Entity integrity just satisfies the 1NF. And what it tells? It tells that no tuples can be duplicate. Right? So no tuples can be duplicate. So for which it matches to? It matches to entity integrity, matches to no duplicate rows in a table, right? And domain integrity means we have a price here, okay, and price can take, let's say, float value, okay. Price can take float value, but if you are putting, let's say, ABC over here, so this is actually violating the domain integrity, because this ABC is actually a string and it is not following the domain integrity, because price should take the float values and you are giving string values over here, okay. Or let's say price can take values from, let's say, 100 to 1000 and you are putting here, let's say, 20. So you are also violating the domain integrity right over here. So domain integrity can be violated in two ways. If you put another data type, or if you put some values which is beyond the range. So domain integrity says enforces valid entries of a column. Enforces the valid entries of a column. Okay. Referential integrity. So referential integrity means the foreign key integrity or the foreign key. So it says that it actually says what foreign key means. So you can take values. Let's say this B is actually referencing to C. Okay. So as we have seen earlier, that B is referencing to C. And that means that B can take only values from C. And let's say if we delete some values over here, like 5, and we have another value over here 5. So 5 is taken over from here, right? So 5 is taken over from here, and if we delete this 5, so accordingly this 5 should also be deleted. Similarly, if this 5 is updated to 6, this 5 should also be updated to 6. This is actually called the cascading delete or cascading update. Okay, so it says that referential integrity enforces some specific, rows cannot be deleted which are used by other records. Okay, so it is actually what we do here, it is actually a cascading delete, but we can also write that no delete constraint to satisfy the referential integrity. So this is actually rows cannot be deleted which are used by other records. Okay, and finally the user defined integrity is enforces some specific business rule. Okay, so let's say you are specifying that this kind of thing. Let's say you are specifying that price can take the values from 20 to 100. Okay, it can take the values from 20 to 100. So this is a specific user defined integrity. So this is specifically satisfying some business condition, that you cannot put values beyond 20, less than 20 or greater than 100. So this is actually satisfying so A is satisfying with 4, B is satisfying with 3, C is satisfying with 2, and D is satisfying with 1. 4, 3, 2, 1. Is it so? No. 4, 3, 2, 1. So our answer will be option 2. Okay. So with this, I would like to end our today's discussion. I hope this discussion has helped you a lot. Okay. So thank you for attending today's session. Okay. Thank you and keep practicing.